In this lesson, you are going to learn how to factor out the GCF out of a polynomial. So this first one, I'm going to remind you of what is the GCF of 14a to the fourth and 7a squared b. So when we've done this problem in the past, we always made factor trees for our coefficients. Okay, so 14 breaks into 2 times 7, and I circle my prime numbers. They're both prime, so that factor tree is done. For this one, 7 is a prime number, so I don't really need to do a tree for this one. And then I list out my prime factors. 14a to the fourth is equal to 2 times 7 times a times a times a times a, whereas 7a squared b is equal to 7 times a times a times b. And then I circle anything that is common to both. And what's common would be 7, we've got 1 7, times a times another a, so my GCF is equal to 7a squared. But really this will become much easier if you can speed up the GCF process. I would like you to be able to look at these and go 14 and 7. What's the largest value that goes into both? I always begin with my smaller number, which is 7. And I think, does 7 go into 14? Sure, it goes in 2 times. So my GCF would be 7. And then I look at the variables. I have an a squared and an a to the fourth, and I think, well, what would I end up circling? There would be 2 a's that would be circled, so a squared. And then there's a b here, but there's not one there, so nothing's in common. You want to try to mimic that process as you go through the next couple examples. So in this one, 3x minus 15, you need to start by identifying what the GCF is. So the GCF, again, I start with my smallest number, which is 3, and I think, does 3 go into 15? Sure it does. It goes in 5 times. So my GCF is going to be that 3. Then I look at the x's. There's only an x on the left and not the right term, so only the constant 3 is part of your GCF. So what you do is you write the 3 out front, open up a set of parentheses, and you divide each term in this binomial by 3. 3 divided by 3 is 1, so I'm left with 1x, which is just x. I don't need to write the 1 there, but if you did, it wouldn't be wrong. And 15 divided by 3 is 5. So my answer here is equal to 3 times the quantity of x minus 5. A way to check it would be 2 things. First of all, you look inside at the remaining polynomial and you think, is there anything bigger than 1 that goes into both of these? 1's the largest thing that goes into both, so that's a good sign. And then the second thing you do is you redistribute. If I distribute 3, I would get 3x, and if I take 3 times negative 5, that is minus 15. So I get what I started with, so that's a good sign. All right, let's find the GCF of these two terms. So again, I look at the coefficients 2, and the coefficient here is 1. If it's helpful for you to write that 1 in, you can certainly do that. And I think, so what's the biggest thing that goes into 2 and 1? Well, it's just going to be 1. And then I look at my variables, a cubed and a to the first. I take the one with the smaller exponent because that's what's shared in both places. So the GCF is just 1a or a. So I put the a out front. If you put the 1 there as well, that's fine. And I'm going to divide each term in the binomial by a. So 2 divided by 1 is still 2. A cubed divided by a to the first, remember, is keep your base, subtract your exponents. So it's 2a to the second. And then 1a divided by a is equal to just 1. So it's minus 1. A times the quantity of 2a squared minus 1. Again, a way to check it is make sure this term here and this term here, the only thing that divides into both of these evenly is 1. If I would redistribute, do I get what I started with? Well, I'd have 2a to the third minus 1a, and that's what I started with. Okay, this next one is a trinomial, my GCF. Look at your coefficients. That would be 2, 4, and 8. Start with my smaller number, which is 2. Does that go into 4? Yes. Does it go into 8? Yes. So my GCF is 2. And then I look at the variables, k cubed, k squared, and k. Take the one with the smallest variable, which is k. Bring your GCF out front, open up a big set of parentheses large enough to fit a trinomial, and divide each of these by 2k. 2 divided by 2 is 1. K cubed divided by k to the first is k to the second. Keep your base, subtract your exponents. Minus 2k, because 4 divided by 2 is 2. K squared divided by k is k. And the last term, 8 divided by 2 is 4. K divided by k is 1. Okay, so this right here is your factored polynomial. Okay, so let's identify our GCF. My GCF here is 3, goes into both 3 and 15, and I take the smaller power of x's, so it's 3x. Now, one little extra thing on this problem. You see how my leading coefficient is negative? We kind of hate that in math, okay? So what I do is I identify my GCF as a negative when that occurs. So I'm going to factor out a negative 3x, which is going to make my remaining polynomial have a positive leading coefficient. So I'm just going to make sure I divide each of these by negative 3x. So negative 3 divided by negative 3 is positive 1. And x squared divided by x is x. So again, if you want to write that 1 in there because you like that, that's fine. I just don't typically write that. And then 15 divided by negative 3 is negative 5, so I put minus 5. And x divided by x, they cancel. So my answer is negative 3x times the quantity of x minus 5. Now, I just want to point out quickly that if you hadn't divided by a negative, you would still get an acceptable answer. So if you had decided to just divide by positive 3x, let's just look at how this would change things. You would be left with negative 1x, and then 15 divided by 3 would be plus 5. So compare these two answers here. They're just opposites of each other. So I have a negative 1 here, here I have a positive 1. I have a negative 5, here I have a positive 5. So if you're doing your practice and Get More Math, it will actually accept the answer either way. It's just the first way I did is the best practice and will set you up for success in future math classes and this math class. Okay, this one here has one little extra thing. This one's not in standard form. We always like our term with the highest degree to be first. So I'm going to write that first. I'm going to put my negative 9a to the 4th first. And then I'm going to put plus 3a squared plus 36a. Again, it's just helping you prepare for what's coming soon. Okay, so now I look for my GCF. Negative 9, 3, and 36. And I think, okay, so what's the biggest thing that goes into all three of those? I start with my smaller number, which is 3, and I check, does 3 go into 9? Yes. Does it go into 36? Yes. So my GCF will be 3. But again, I got that leading coefficient that's negative, so I'm going to make it negative. Negative 3, and then I take the variable with the lowest exponent, so negative 3a. Put that out front, and I'm going to divide every term by negative 3a. That gives me 9 divided by negative 3 is positive 3a to the 3rd. Keep your base, subtract your exponents. 3 divided by negative 3 is minus 1. A squared divided by a is a. And then minus 12. These a's would cancel. Here is my factored polynomial. Now, if you didn't realize that this was not in standard form, honestly, Get More Math would accept it in the jumbled order, but again, best practice is to rearrange it. Why don't you pause the video and try this one on your own? Okay, hopefully you noticed that this one is not in the right order and you started by readjusting it. Putting the r to the 4th first, the minus 36r to the 3rd second, and minus 18r squared last. Okay, so you're just going by your degree in the descending order. If you miss that step, technically it's okay. Our answers will just be in different order. Okay, so I identify my GCF. My GCF Look at 12, 36, and 18. The smallest number, 12. Does that go into 36? Yes. Does it go into 18? No. Okay, so then I'm going to need to do something smaller. What are my factors of 12? Well, 2. 2 would go into all of them, but how about something bigger? How about 4? 4 does not go into 18. You might have to test that on your calculator if you're weak. 18 divided by 4, you'll get a decimal. How about 6? 6 goes into 12, 36, and 18. Okay, so it's going to be negative 6 I'm going to go with. Negative 6, and then I'm going to take the variable with the smallest power, negative 6r squared. So I put the negative 6r squared out front. And I'm going to divide each term by negative 6r squared. And let's see what happens. Negative 12 divided by negative 6 is positive 2. R to the 4th divided by r squared is r to the 2nd. Keep your base, subtract your exponents. Negative divided by a negative is a positive. 36 divided by 6 is 6. R to the 1st. And then plus 3, and these r squareds would cancel. Okay? So again, to check to make sure you got the biggest number, look at these coefficients inside. The biggest thing that goes into both 2, 6, and 3 is 1. So this is completely factored. Okay, if you have any questions, please reach out to any of us. Show us what you know.